Welcome to Pavithra Laptop Care. Today I have received a laptop. It's a Dell XPS. Okay, model number is Dell region model number P91F601. Okay, this one is 10th generation i7 laptop. What is the problem? We will check. Okay, this 6.5 amps 20 volts. The problem is completely dead. In this case, how we can identify the problem, where exactly the problem, that for our PLC students I am going to give some ideas, especially for PLC student, because I already done some chapters for them, but here is a live case has come. So how to identify a problem, that I am going to discuss in this topic. Let us open the schematic first. We will check the motherboard model number. See, when we open the motherboard, first basic step is, if you are fresher, first basic step you have to understand what we have to do. Don't be panic. So it's a 10th generation i7, it's the costliest laptop. Not like that. Actually, don't be panic. If you know the procedure of troubleshooting, then easily you can identify the problems. Okay. See, here is the motherboard. Here is the model number. Here is the model number. What is the model number? LAJ191P. Okay, this is the model number. As per this model number, first we need to open the schematic. Generally, we can observe in what condition it is there, any short or not. That first we need to identify. When we examine this, some R&D has done from previous vendor. But anyway, this charging IC section, they has done many work. PO100. Here are some components missing. I will show you where is the charging IC. Just you observe the board. You can't find out the charging IC here, right? So I will turn it out. See here. This is the intercell, something like that. This is the charging IC section. Okay, anyway, first we will check the schematic, and first we need to understand what is the problem and how to read the schematic and what will be the exact problem. Okay, let us come to the schematic. Here I have opened the schematic. This is the part number LAJ191P. Subpart numbers here 821P, 822P. These are data boards. Okay, first, generally what we have to do, see, one thing I'm going to tell you people, even including PLC students or outers also. Till now, some concept was there. So first step you have to check this one, and then it will create this one like that. But in 10th generation onwards, all concepts are going to ulta palta. Means some concept may be first and some concept may be last, like that. So first, generally we will open the charging section, right? Directly that CLR output will be going throughout the motherboard, right? So but now in some cases, when type C concept started, from that time some changes happened. Depends on charging IC. Okay, that I wanted to discuss today. So now generally what we will do, first we will go to search and we'll check charging, right? Charger. as per the old concept only I'll discuss first, then I'll tell what exactly we have to check. Now see, I'm searching the charger, where it is, charger page. Here is the charger. See, ISL 9538 CHRG-Z. See, this one is 10th generation i7 laptop XPS. It has type C turbo Thunderbolt. In this, so how it will work? Actually, in type C, any type C, initial voltage will be 5 volts, right? But for laptops, we required 20 volts minimum and 6.5 amps it's taking in this particular motherboard. How it will convert? The concept I'm not going to discuss today's topic. Some other day I will discuss. But the thing is, in basically the 5 volts will convert to 20 volts. It depends on type C sensor and type C drivers. Okay, what is the type C sensor and type C drivers? In this particular schematic it is there, but anyway, so I'll come to the point in other day, okay, not today. Generally, what will happen for charging IC, usually 20 volts concept will be there. Always 20 volts concept will come to the, what is that, where? Here in CLR. Okay, here there is no first MOSFET, there is no second MOSFET concept. Directly the charging section, type C section will convert to 20 volts and it's directly giving to CLR. See, this is 20 volts, V in 20 volts plus charge V in 20 volts, 5 to 20 volts variation, B plus 9 to 13.4 volts from battery. Here it's a 130 watt and frequency 700 kHz. Okay, see, now this is the charging IC. So what will be the input? Generally what we'll check, all inputs we are checking, right? So here my question is, which voltage has gone throughout the motherboard? That is my question. I'm asking you, to the particular PLC students, even others also, what voltage will go from here? See, in this particular IC, what voltage it's generating and which voltage is going throughout the motherboard. It's a CLR voltage, this one or this one or this one. First we need to generally discuss which voltage is going throughout the motherboard. First concept. Okay, without this concept you can't repair the motherboard. Some blindly you can check that coil voltages and you can repair it, but as per the rule, as per the schematic, as per the professionally, so you have to think about this part, which voltage is going throughout the motherboard. See, first we need to check charging IC inputs. PU1900, I already explained you, I showed you in the motherboard. Someone has done the work. See, here is the charging IC name, ISL 9538 CHRTZT. Okay, here DC in is the input. DC in, what are the inputs? First we will check DC in, from where it has come. See, here it's a B plus and this one charging point, B plus and charge V in. See, this one charge V in 20 volts, that I already told you. When you connect the type C, a converter driver will be there, that driver output will be the V in 20 volts. That's coming to the CLR. Generally in all laptops this CLR voltage will go throughout the motherboard. Okay, now we will check, is this going throughout the motherboard? See, I am searching this. The answer is no. Okay, and what about this coil output? I will copy and I will search. See, only one part. The answer is no. Not even this and not even this and not even this also gone throughout the motherboard. Then which voltage here it's used? First we need to identify that. Okay, usually in charging IC there will be two CLR. One is adapter side CLR, other one is battery side CLR. Now we confirmed this adapter side, AC side CLR not going throughout the motherboard. Now we are going to check this CLR is going or not. See, here is the voltage B plus. Is this the voltage is going throughout the motherboard? Shall we check? Okay, I am copying this and paste. Enter. See, B plus 9 volts to 13.4 volts. See here 71. Here B plus, again that B plus has gone to the pin number 3. Okay, this I see. Next B plus PD 1902. See, that same B plus is connecting to the charging IC. That's common in any charging IC. Battery and AC voltage will be connected. Second one is, see here it's high MOSFET. See, usually what are the CLR voltage? That voltage will goes to, that's a V in section, will goes to the high MOSFET of any section, any high-low MOSFET sections, right? Here B plus is the battery voltage has gone to the high MOSFET input. Next, see here B plus is the input, PU 500, this IC. What is the IC? IC is 1 volts always. B plus is the input. In this B plus is the input. In multiple section B plus has used. See, here is the answer. In this particular motherboard B plus has used throughout the motherboard. So B plus, from where it's appearing? Here it's a concept little bit change compared to previous motherboards. One is, previously generally what will happen, 99%, I mean almost 90% this CLR voltage will go throughout the motherboard. But nowadays what are the laptops are coming, higher end laptops, all are using, especially Dell I have seen, in many laptops this CLR voltage has gone throughout the motherboard. Okay, here is the answer. First we need to check this B plus is present or not. That is the first point, basic point. Before that, AC side is this voltage is appearing or not, this also we have to check. It means PR100 and this one PR, what is that, PR1910. This both CLR voltage is available or not, first we need to check. Here VBAT, it's a battery voltage. When we connect the battery, it comes through this particular MOSFET, and in this CLR battery voltage will appear. Okay, this B plus, first point what I told, CLR voltages first we need to check. And one more thing, in this particular charging IC, see here 3 volts always. Initially I told some basic points will be ulta palta compared to previous motherboards. Okay, here just one question, a question I am asking you people. See, here it's a 3 volts always. First, before charging IC section, how 3 volts always input has come here? Right, here is the main question. It means initially first 3 volts section will activate. Right, how it will activate without that CLR voltage? See, here when you connect the battery, that concept I am going to clear now. When you connect this battery, here this CLR voltage will appear. This CLR voltage will appear as B plus. Okay, this B plus will be the input to this pin number 3, pin number 17. Okay, here clear, I think so. See this 3 volts always, how it will generate? Using this B plus. See, once B plus voltage will come, this through this coil, the voltage input to this particular IC will generate. See, V reg, V reference 2, and here is the input. What is the input for this? 13.5 volts. This is a high MOSFET input, and the second thing is V in. See, 13.5 VB, 35 volts. This one is from where it has come, that we will check. See, copy and paste. V in. See, only 2, right? So this 13 VB is generated through this B plus. Okay, after this coil, the name called as 13.5 VB. This is the input for this particular IC. See, when input it gone, it received, so automatically it will receive the enable also. See, once input has received, it will generate V reg 3 and V reg 5. That concept you know very well, right? See, this 3 volts VLP and 5 volts VLP is not used in this motherboard. That's why it's not mentioned here anywhere. This is the input, and here only 3 VLP concept has used. Okay, and second thing is how it will activate, how it will produce 3 volts always. That we come to know. See, this is 3 volts always IC. Here is the enable 1 and enable 2 has given. What are the enable 1 and enable 2? ALWON, ALWON. See, this ALWON. From where it has come? Shall we check? From where it has come? This one we'll copy and we will paste it. Type. B, no. See, generally here is the input, it asking next. This is IO. Where it is? Here WON. See, next. See, it has gone to IO. It's coming from IO E6. E6, is it IO? Yes, it is, because MEC 5107 IO has used here. It has come from the pin number what it is, E6. This is always on output. So the same always on enable signal goes to where? 3 volts IC. See, here is the enable 1 and enable 2. Once this enable will occur, see this one, how it will generate, the IO should be activate. When it will activate, once it gives the region 3, that 3 VLP, general concept I already cleared. Once 3 VLP will get, the IO will activate. Once IO will activate, that gives this particular enable signal. Okay, this is a signal. Always on is the signal. Enable 1 and enable 2 both are the signals. One signal comes, these 3 volts always and 5 volts always also will generate. Okay, this is the concept. First what we have to understand, first we need to check what is the basic voltage has gone throughout the motherboard. That one is B plus. Okay, B plus. it has gone to this pin number 3 and as well as pin number 17 DC in. Okay, after that this charging IC adapter, once you connect the adapter, this voltage we need to check. These two are very important voltages. Okay, here it has given a clue. V in should be 5 volts to 20 volts. 5 volts, why? It's a type C charger. If any short will come there inside that charger, so you will get only 5 volts, not 20 volts. The driver IC will convert to 20 volts. Type C driver. Here is the B plus. B plus is the battery voltages. Once battery will charge, this constant output will go throughout the motherboard. Okay. Now, will you check these two voltages? Yes or no? Okay. Yes, you have to check. It must. Okay. Once AC voltage appears, then adapter. See adapter. Here also one input is there. Pin number 16 and 17 both are inputs, main inputs. After DC in general concept, AC in, we have to check AC in. Here it's not given, so where it has given? Here it has given here. See, same thing as given here. AC in ISL 88738. This is the voltage has gone to AC in. How it's going? It's going throughout the voltage divider. Okay. First we need to check inputs. This AC in voltage divider, what will be there according to this divider? We have to calculate that particular voltage has to come here. According to this, AC OK will generate. According to this, AC OK will generate. What AC OK will do? This is the main role. This is the very, very important signal goes to IO. Because when you connect the adapter, the symbol, the indication has to go to IO through this AC OK signal. If this is in active mode, it may be low or high, it depends on particular IC. Once it active signal has goes to the IO, then IO will think AC has connected. Then only your battery will charge. Then only your battery will charge. Keep it in your mind. Once AC OK signal goes to the IO in positive manner, then your battery will charge. Means battery charging related signal will active. Okay, without this signal, it shows works through only through battery. If you connected the AC also, it won't work through AC. This is most important signal. Okay, here is the basic concept, basic voltages we have to confirm. Once you receive any dead motherboard, first you need to observe what the model number, and after that according to the model number you have to open the schematic. Once you open the schematic, first you need to check the charging section. In that charging section there will be two CLR voltages. In that particular CLR voltages, what voltage has gone throughout the motherboard, first you have to identify. Once it identified, then you have to check this IC inputs. What are the inputs? After these inputs, what will be the AC in, and according to that AC in, this AC OK will generate. Through this AC OK signal, IO will consider adapter is connected. Then only you will get the 19 voltages. In this concept, in this particular motherboard, 3 volts always also has gone to the where? Gone to this charging IC. Usually 3 VLP will come to this particular charging IC through that SDA SCL pull up. But here 3 volts always also has given to this CM out. Okay, this CM out, once you check the concept, then only you come to understand, come to know what exactly it is. Okay, see, these are the basic steps. In next video we'll come to advanced level, how to troubleshoot that particular motherboard and what will be the result, it will be okay or not, that in next video we can check. Okay, thank you very much.